Have you ever wondered how a 3D CAD model is transformed into a 2D mold drawing? In this video, I will take you through the complete process step by step from extracting the design data to 2D drawing and even checking the accuracy before releasing to the workshop. This guide is very useful for the student, design engineer, tool maker, or anybody who is curious to know about plastic mold and its working. So friend, first understand the basic. Okay, a 3D drawing only show the product or tool, but for manufacturing, tool maker need the dimension. What are the tolerance? What are the its fits? What are its? It includes the critical detail like dimension, tolerance, section view, and machining node information that is not always clear in the 3D model. They need the 2D drawing for manufacturing it accuracy. Friend, the process start with the 3D CAD model. The process with finalizing the 3D CAD model with the model must be checked thoroughly for our draft angles, wall thickness, undercuts, and parting line. These checks ensure that the part can be manufactured without any issue. You can check the core or cavity or runner or ejector pin or any accessories that are included in the tool. Okay, friend, the next part will be extracting the design data before creating the 2D drawing. We extract important design like CAD, like overall dimension, feature size, hole, and specific material. Okay, some CAD software also generate automatically report of the volume weight. Okay, so it is useful for our mold calculation. Friends, you must check thoroughly the parting line, core, cavity inserts. Okay, before going to the 2D drawing. This define how the mold open and ensure proper ejection of the part. Okay, friends, the next part will be our generating the 2D views. We go to the drafting. In the 2D views, you find the core, cavity, all the section and the internal details. This is required for our manufacturing team. You can see here the general view of our moving half, fixed half, core insert, cavity inserts, our ejectors, okay, the runner details. These are all the general view that are given in our assembly drawing. You should check the title block also, okay, and you should check all the BOM that is been given with the drawing. You should check thoroughly what are the dimension, what are the tolerance, what are the fits, and any remark if any it has. Right, you can see this is the assembly. This is the overall overview of the mold. Okay, you can just go through it if the dimension are correct or not. This is the overall dimension that is given. This is for the insert and other. There will be a separate drawing for our ejector pin, insert, slider or lifter if it is have. Okay, these are the overview of the. This is the assembly drawing of the tool. There will be a separate drawing for inserts and other parts. We will see also that one. You can see this is the ejector pin they have shown. Okay, ejector assembly. This is the detail of our runner edge gate. Okay, this is also the runner. Okay, how much the distance and what is the feature. Okay, you can see this is the fixed half, this is the moving half. Okay, and the section is been cut. You can see this is the AA section. It is cutted from the center. You can see this is the our register ring, screw bush. From here runner came. You can see this is the one more detail. This is the EE view that you can see here. Okay, I hope you clear it. This one. These are two section view that are been given, section AA and section BB. You can see the section A. I will show you the section A. You can see the section A is cut from here, and it is going from the center, and it is going from here to here. Okay, and the section B is, you can see it is cutting from here, going from this center and from this one to runner center, and it is going from here. Okay, so you can see the section view, so that you can see maximum detail of the this tool and what are the dimensions that are all given. We start with the top register ring, okay, screw bush, then the runner will come from here, okay, and it will go to the product. One more detail view is given, CC. This is the CC. You can see here the runner detail is being given. This is our cavity insert, cavity plate, core plate. This is our puller pin. This is the ejector pin. Okay, ejector plate, ejector back plate. Okay, spacer. Okay, and the bottom plate. These are the part. This is the assembly drawing. You can see. These are the all the details that are being given in the assembly drawing. Okay, friend, this is the core insert, main core insert. Okay, you can see there are different tolerance are given. This is plus 10 micron. Okay, you can see this is the control dimension that are given. Always we have to check the critical feature of the cavity, ejector pin, or some sliders or lifters it has. You see this is the control dimension. This is also 10 micron. You must check all the control feature that are being given in the drawing. Okay, friend, we must check all the critical dimension feature in cavity, core, depth, ejector pins. Okay, friends, cooling channels, because these are very precision dimension needed. It may be flatness or squareness. Friend, we must check that GD&T is applied where our precision is needed, such as flatness, positioning, or concentricity. Now we look the friend, this is the bill of material or BOM of the mold. It is added to the list all standard and custom part such as guide pin, ejector plate, ejector pin, bush, and all other general note including machining, heat treatment, and assembly instruction if it is you can see the main cavity insert, core insert, its quantity, size, finish, material. Okay, you can see the all other standard part also like locating ring, screw bush, mold lock, support pillars. Okay, these are all standard parts. Guide pin, guide bush, these are all standard parts, and this is the our mold base. Okay, top plate, cavity plate, core plate, support block, this is all come in the package. You must go through all the things. This is the BOM for the particular mold. Okay friends, some points to be remembered. Friend, before releasing a drawing, always check for the accuracy. Here are the some of the tips. Okay, cross check the dimension against the 3D CAD data. Verify tolerance and GD&T were applied okay correctly or not. Ensure the scale, unit, okay, and the title block is up to date. Review the BOM for missing component. Make sure revision number, title block, all are up to date. Once verify, the drawing is finalized and released for manufacturing. Accuracy here, a toolmaker can build the mold with confidence, and that is the complete journey from 3D CAD file to the professional 2D mold drawing. By extracting the data, following drawing standards, and carefully checking accuracy, you can create reliable mold drawings that are ready for the production. Now you know from 3D CAD model to 2D drawing. Welcome to the UG Mold Tech. If you found this video helpful, do not forget to like, share and subscribe, and if you have comments below.